Hey everyone, welcome to a new video. It's Federico here, and this is the first video since Max 9 is out. Although in this video we are not going to see any Max 9 specific things, but we are preparing the way for Max 9 specific things in the next videos, building the knowledge in order to use the new stuff. Before we start, I would like to say that all the knowledge basically that you will see in this video and possibly the next ones comes from Matteo Marson. He is the guy when it comes to rendering and rendering algorithms, how to make stuff look good. He's the best. So what I'm telling you here is basically what he told me. You know who to thank for that. So in this video we're going to see how to make stuff look good in Max. So we're going to build a little scene and then we're going to see how we can make it look like this, which looks a bit better than just if you will place these objects in a scene and not touch them, right? So we will start by building the scene and then look at all the other objects that will make this happen. So without any further ado, let's jump right into it. Strap your seatbelt, hold on to your hat, and have fun. Alright, so let's start from scratch. Let's create our JIT world, floating one, and full scale anti-aliasing. Let's enable it by default, and I think this is it. So just to check if it's enabled, we can create a jit.fps GUI object. It's called jit.fps GUI and looks good. So let's create a little scene here, a little 3D scene. So let's create a GGL grid shape and let's maybe make it a cube. And this cube is taking all the screen, right? So if I want to zoom a bit out, we can create a jit.gl.camera. Give it look at 0, 0, 0, giving the lock look 1 attribute. This is all stuff that I explained in my previous videos. I actually have a series on like introductory to GL objects, so I will put a link in the description, no worries. So look at, and then let's give it tripod 1 as well, which means the camera will not tilt. Let's create a jit anim drive with UI listen 1, which means we can now use our keyboard to move around in the scene. Sweet. Let's reduce the ease to like 0.1. So yeah, it's a bit more like snappy, the camera action. Cool. So we got our cube here and let's scale it so that this becomes like a floor. So scale, let's make it like 5, 0.25. And now this looks like our floor. Let's create another GGL grid shape. And let's make this a cylinder, for example. And where it is there. Let's make it red so we can see where this is. It's right there. Let's maybe rotate it. And you know, we can use the new auto handle feature of JIT World to use the new widgets to rotate. Move. I'm pressing Ctrl now to go in the moving mode, and then we can scale. I'm pressing now Option to scale it. So yeah, like this I can scale it, and I will put it a bit here on the left. Maybe it's a bit too big, so we scale it a bit down and a bit on the floor, and this looks good. When I'm satisfied, I can go here on the shape. Click on this, unlock the patch, click on this green triangle and go change attributes to arguments, and this will save the position, the rotation. We don't really care about the material. GR color I already gave it. The scale we want. Good. So now it's kind of hard coded all the attributes that I set with the handle. Cool. Let's create another object. Let's make it a GGL model. So I will use that to import the doc.dae model. And there she is. Let's again, oopsie. Oh, I didn't want to move the floor. I wanted actually to move the doc. So let's rotate the doc again. Let's move it and rotate it using the auto handle again. And there she is. Let's go again here, transform, change attribute to arguments. Okay, perfect. Let's maybe create another grid shape. So let's make this a sphere. There it is. Let's give it another color so we know where this is. There she is. And let's click on it and move it around it with the handles again. Here. So maybe scale it a bit smaller. And it became kind of an oval because I'm not really sure how can I scale with all the three axes at the same time. So that's kind of tricky. There she is. Maybe it's an egg from a duck. Cool, it's green. It's not, maybe it's not a great egg, but looks good. So change attributes to arguments again. We don't need the matte diffuse. We don't need the GL color, but all the rest we want, all the transformations we want. So scale, rotation, and position. And cool. Let's be satisfied and let's say this is our scene. I will turn out the auto handle so I don't move stuff by mistake. Cool. So I'm going to put a bunch of comments here to see what is what. Cool. So let's make this thing look good. How do we do that? Well, the first object we want, we could either use the GGL material object, but for these tutorials, I want to use the newer object, which is the PBR object. So PBR stands for physically based rendering. And this is what will allow us to achieve the most realistic results. So let me get this. And I'm going to connect it to each one of those objects. Will receive one of those. There we go. And as you can see, all of them became gray because the jit.gl.pbr is overriding the material settings of the objects. So the lighting calculation, the color, and yeah, basically those. And it's replacing it with a physically based rendering. So now everything looks gray. As you can see, the duck also lost its texture. So actually, if we right click on the GGL model and get the attribute material mode and we select number 3, the duck will get its texture back. But if the duck has its texture back, we cannot really use the properties of the PBR. So there is another way to get its texture, but for the moment, we will go full PBR, and then we can set the color of those objects using the matte diffuse attribute of PBR. So, for example, here the cylinder, I will just assign the color that I've used before. So 0101 for green. The egg, so matte diffuse. Let's make the egg maybe a bit more yellowish, maybe a bit more blue, right? Yeah, these I like. The duck, let's make it yellow, so matte diffuse 1101. There we go. And the floor, let's go on the floor, matte diffuse, and let's give it, I don't know, maybe, let's give it like, yeah, this sort of bluish color. I miss like a splash of red. So what I'm going to do is to copy that grid shape, give it a red color, and I'm actually going to make it a cube. So I'm going to take it, move it, and then I'm going to rescale it a bit, just so we have like a nice splash of red. And let's maybe rotate it a bit. Cool, some sort of panel. And then again, right, click on the triangle, transform, change attributes to arguments, and that's it. We don't want the auto material. You can also leave it, it doesn't hurt for sure. It's just that it's not necessary and it's just using space for no reason. Now this scene, it looks better than before for sure, but it doesn't really look good, right? So what the PBR allows us to do actually with the physically based rendering is to get an environment into our scene, an environment map, and use these to lighten the objects in the scene. So what we need for that is an object called jit.gl.environment. And then if we go into our file browser, which we can recall with command.b, and we look for files that have the EXR file type, we can see, for example, that there is one called Langa Sunrise 2K EXR. And what I'm going to do is copy the file name, go back to our patch, and say file, and then just pass that. And as you can see, by default, the objects are now illuminated by this environment. They are lightened up by this environment, like if they will be inside that scene. So that's how that file looks like. It's an image in the format EXR, which allows us to have high dynamic range images. And it's completely deformed because this gets mapped to a sphere. So this is deformed in a way that when we wrap it around a sphere, then this looks good. This file is built in Max, but you can load every EXR that you want. And I will put a link in the description to show you where you can get such images. Okay, cool. But can we actually visualize that environment? Of course we can. And we can do that with an object called jit.gl skybox. And there we go. Once we create it, it automatically gets the file from the jit.gl environment and uses it as a texture for a sphere that is around our world. So now we have our scene in that environment, which looks pretty cool. So let's see for 1 second again the difference between no environment and environment. It's drastically different, right? For example, this allows us to create reflections. I can, let's go to the dark, for example, in the PBR, and I can say that the dark is roughness 0. And then you can see that it starts to reflect the environment much more. And I can also say that it has metalness 1. So like it's completely reflecting the environment. But that's not what I want to do for the moment. What I want to do is to show you how we can use a jit.gl light to affect the scene and make it more realistic. Let's create an object here called jit.gl light. Now the jit.gl light is, if I create it, nothing happens because there was already a jit.gl light by default inside a Jit world. It's kind of wrapped inside. And by creating it one explicitly, I'm just basically taking control of the default jit.gl light, but I'm not changing anything because the light was already in the scene. So what we can do with the light is to change, for example, the diffuse color, which will change the tint of the light for the scene. As you can see, it's having an effect. But when we use jit.gl.pbr, so physically based rendering, you have to think about the light as something that is as not only a color, but also an intensity, so like an energy. So you have to think about the energy of the light. And what does this mean? It means that we can go with the colors, we can go above the value of 1 when setting the diffuse color of jit.gl light, for example. So we can do, for example, something like that. We can get a swatch object that when we use it, this is called swatch. And when we move this circle here, it will give us the color that is under the circle in the format 0 to 1. So what we can do is to then multiply that with the expr by some value, and the value is going to be a scalar, so we have to say scalar mode 1, and we could use the value 30, for example, to multiply those colors that come inside by 30. So let's see what happens then. As you can see, the colors are now in the range 0 to 30. So we can then say prepend diffuse, and that's going to be the color for jit.gl light. And as you can see, the scene gets like much brighter and almost overblown if the color is too bright, right? So let me actually drop another environment here. And this is just a blue sky, kind of stylized. Let's maybe use here a load mess with the value 30 for the color multiplication. And okay, so as you can see, now I'm choosing like a yellowish, very yellowish light. And the scene is overblown, like the color is too bright. We're losing details because the values go all above 1, and so we start to lose details in the objects. To make this a bit more clear, let me get another model. So I'm getting a model that has a bit more details. This is an object that I downloaded from the internet, from Kenny. I will put a link in the description for the package of objects as well. So that's a little tower, pretty cute. And again, I moved it around using the auto handle of Jit World. And actually, the material mode by default is going to be 1. So if I want to use the color from the PBR, I have to say material mode 0. And once I got that, I can change attributes to arguments. And I didn't have to put the path to that file because it's already in my max search path. But if you use, if you want to auto-load a file that is not in your search path, you should put the whole absolute path of the file. So let me delete these attributes which are not necessary. Okay, cool. So this tower is kind of more sharp edges. Let me do the same for the duck. So material mode 0. There we go. So what we were saying is that the colors get like overblown and we start to lose details. If we make these number higher, and let's actually like trigger also this watch every time we change this value, you can see that at a certain point we start to lose detail because everything is overblown. So there's a way to correct that, and that is to use tone mapping. So tone mapping will remap the color values of the scene in a way that will diminish the super high. So it will adapt the color response of the scene, let's say, to the eye perception of the colors and give us more details in the process by reducing kind of the super high. So in order to do that, we can use a path with a path called gamma. Now, when we use the gamma, something is going on. Basically, let's first talk about what is the gamma in general. So the computer screen expects the colors to come in a color space, which is called sRGB. That's mostly the case. Some screens use some different color spaces, but mostly is sRGB. While the colors, when we create like a GDL grid shape and we give it a certain color, that color is in linear space. So let's 1 second delete the gamma. So if I create a GDL grid shape and give it the color red, this color is now in linear space. And while the computer expects the color to arrive in this sRGB space. So the colors are linear when we create, for example, a grid shape without any jit.gl.pbr attached. Okay, as I just did. And this is actually a problem because this color is in linear space while the screen expects it to be in sRGB space. So if we don't do anything about it, this is actually wrong. And I've been doing it wrong for years. So in all my tutorials, I never care about that. But it's actually the wrong way. So when we connect the jit.gl.pbr to that object, it will, let's give it the color red again. So matte diffuse. So this will transform the color from linear space into sRGB space, and that's correct. But if you want to use the GGL pass gamma for doing the tone mapping thing, oh, and that's actually the fx name gamma, right? What happens is that the scene gets all messed up and kind of milky. And that's because the jit.gl.pbr is already applying gamma correction and the gamma pass is also applying gamma correction. So what we need to do is to go in the jit.gl.pbr in every one of them and just turn off the gamma correction. And when I do that, as you can see, this object looks correct, while all the others still look milky. So let's go and do that. So for every object, let's say gamma correction 0. For every PBR in our scene, let's say gamma correction 0. Okay, so that's it. Now we can use the gamma pass. And the problem is that the jit.gl environment also applies gamma correction by default. As you can see now, the sky looks milky as well. So what we need to do is to go into the GL environment and say gamma correction 0. And it will load the other file automatically. So we just reload my file. There we go. Cool. Now we can go into the jit.gl pass and say tone mapping 1, or we can set it to 2, for example. So each number represents a different algorithm. The 2 one, it's looks better, in my opinion, than the algorithm at 1. So this will be the algorithm at 1, this will be the algorithm at 2. So I like the 2. And then we get another attribute that we can play around with, which is max white. But the max white parameter only works if the tone mapping is set to 1. It looks like. So let's set it maybe to 1. Let's play around with the max white. Or we can just set to 2 and not care about it. So what we achieved in this way is that we can now set directly a certain amount of energy for our light. So for example, we could have like a super bright sun that is engulfing the earth or something. Or we can have like a pleasant evening sun. We can also adjust the color for that. For example, we could have like an evening sunset light. Or we could have like a super bright sun. So the main thing to bring home from this video is actually the gamma correction part. So let's summarize it. When we create an object in our 3D world, its color will be in linear space, which is not what the screen expects, so we need to convert it to sRGB space. We can do that by either attaching to it a jit.gl.pbr with the gamma correction attribute set to 1, or create a jit.gl pass at the end with a fx name gamma. And this also allows us to do the tone mapping thing, so map super bright colors to a range that is more friendly for the human eye. And if we use this jit.gl pass at the end, we have to set the gamma correction to 0 to every object that uses gamma correction. So jit.gl.pbr, jit.gl.environment, and that's basically it. As a last thing for this video, let's activate the shadows from the camera. And as you can see, now we got shadows in the scene, but they look really bad. So in the next video, we're going to see how to fix that, how to make the shadows look very good. For the moment, I want to stop here with this one. I don't want to put too much stuff on the table. So to recap once more, PBR to get this physically based rendering, setting gamma correction to 0, because we mostly want to use this jit.gl pass at the end that does the gamma correction and the tone mapping. Use the light as energy and the color instead of only color, so multiply the diffuse color for a value that you want to give it like more or less energy. And then load an environment with a jit.gl environment object and display it with the skybox object. That's all there is to it. Thank you very much for watching. In the next videos, we are going to talk about the shadows, talk about how to make this scene look much better. You can find this patch on my Patreon. It's up there for supporters. Big shout out to all my supporters. This will not be possible without you guys. Just know that. So thank you very much, and I will see you in the next video. Ciao.